Hi again, this is Mac Lobdell with Pelion Device Management. In the last video, we got our board connected and registered with the service. In this video, we're going to review how to monitor it and launch firmware update campaigns. We're continuing along with our tutorial on GitHub using our PSoC 64 board. Okay, let's talk about monitoring. Pelion uses lightweight M2M for its resource model. Lightweight M2M is a standardized device management protocol specifically targeting low-power devices, where there's a digital representation of device resources in the cloud. Resources are defined by the application, and you can use this to monitor the health of your devices or get alerts if conditions have been exceeded. You can interact with device resources with get, put, or post methods, similar to HTTP, and you decide which methods are enabled for each resource. In our example, we've just provided a few simple resources that can be monitored and updated. In this specific example, we are exposing a digital input counter that on the device just keeps automatically counting upward. And in the cloud, you can view that value and you can put a new value to reset it. Let's take a look at the device application in the main.cpp file. If you scroll down to the main function, you can see that initially it's setting up resources required by the application, and then it will connect to the network, get an IP address, and initialize more items, and then start the Pelion client. So the next thing it does is define its resources, and the first resource to be defined is our digital counter. And as you can see, you can get the resource or you can put the resource from the cloud. And there is a function that increments the value, and that is here. And that runs about once a second. And then there's also a callback function that gets set up to print a message when you update the resource remotely. So let's see that in action. On the serial output of the connected board, you can see that the counter is incrementing about once a second. Let's log into the Pelion Device Management console. Go to Device Directory and find your connected devices. It should be registered. Go to Resources, and let's scroll down to the resource that ends in 5501. You can look at its value, and then you can put a new value. I'm going to set it to 1 and issue a put command. And you can see the device received the message and adjusted the counter value accordingly. Next, let's go to the post resource, which ends in 5850. It's a digital output. And since this resource is not gettable, we can't see it, but we can issue a post command, and no data is required. And if we issue that, we can see that the post was executed. Note that you can gain access to this data over REST APIs, thus it can integrate right into your cloud applications. Now let's talk about the firmware update. If you recall, in the last video, we ran a command that initialized the manifest tool with our account access key. At that time, it also generated a firmware authority key pair. Also at that time, the manifest tool generated a certificate that embeds the firmware update public key. It's a lot like the Bootstrap certificate used to protect the device's connection to device management. However, the firmware authority provides an extra layer of protection for the firmware update process. This certificate got compiled into our application and flashed to the device's memory. Later, when we want to update the firmware over the air, we will direct the manifest tool to create a manifest. Manifests encode information about the firmware update, including the specific location of the firmware payload download, the version of the firmware, the hash of the payload, and so on. It gets cryptographically signed by the firmware authority private key. This ensures authenticity and integrity of the firmware update payload. During the firmware update campaign, the manifest gets sent to the devices. Each device verifies the signature using the corresponding public key stored in its firmware authority certificate. If everything is correct, then the device itself will determine that it can start downloading the firmware payload. Let's review the full firmware update process. Pelion Device Management allows you to manage large-scale firmware updates on thousands of devices, as well as just update one, and that's what we're going to be doing later. Firmware updates are accomplished by uploading firmware and manifest to the service. You define which groups of devices you want to send the updates to. Pelion then notifies the devices that an update is available. The devices respond to let the service know they're ready. And then Pelion supplies the manifest. If everything checks out, they download the firmware image. Then they reset themselves, boot the new firmware, and then report their status back. Let's get back to our tutorial in the updating firmware section. And the first thing we're going to do is create some changes in our application to create a new version. Under the top level of the application, in the target CYTFM folder and then policy folder, open the file CYTFM Pelion policy. Scroll down to the section with ID 16. Find the version and increment it. In my case, I'm on version 1.9. I'm going to change it to 1.10. And then save that file. Now I'm going to rebuild the project by clicking the build icon. And I'll wait for that to complete. Under the build CYTFM ARMC6 folder, you will see a file with the name of the project _ upgrade.hex. To convert the output file to a format that we can use in the firmware update, we're going to run a command to convert it from hex to binary. So I will copy that. So from the top level project folder, paste the command. Adjust the project name if you're using a different project name, and then run the command. This creates the binary file. Now we're actually going to run a command with the manifest tool that will handle everything for the firmware update campaign for us, including uploading the firmware image, creating the manifest, and launching the campaign. So I will copy that. And we need to update a few things in that command, including the firmware version and the device ID. The firmware version needs to be encoded in a 64-bit unsigned integer, where the upper 32 bits represent the major version and the lower 32 bits represent the minor version. And there's a handy formula for calculating the 64-bit value, which is 2 to the 32nd power times the major version plus the minor version. And in my version, I'm updating to 1.10, which calculates to this large number. You can get the device ID from the serial monitor. When the device first registers, it prints its ID. On the terminal, I will paste the command. And I've already updated my firmware version and my device ID. Now let's launch the update campaign. Okay, the campaign has been started, and it's now notifying the device. So if I go to the serial monitor for the device, we should start to see the device downloading the update. So it's already received the notification in the manifest, it's approved the download, and it's starting to download the new version. And this will take a few minutes. You will notice that the application continues to run as it's downloading the new image. Okay, the firmware payload has finished downloading. When the firmware downloads, it gets flashed into the external storage. Now the bootloader is started, and it's looking at the external storage for the update, and it's copying it over to the internal memory. And remember, since the application has been signed, it won't run anything that's not authentic. Okay, the new application has started up. It's connecting to the network and re-registering with the service. And we can now see that the new firmware is running. Again, if you have any trouble, be sure to check out the troubleshooting tips in the tutorial. So now we have a connected device with a secure and trusted identity and a secure connection to device management. And we can monitor it and keep its firmware up to date. The device can't run any inauthentic firmware, and it can't even download any inauthentic firmware. And it has isolated and protected security functions that thwart would-be attackers. I hope you agree that this is a great platform for your next IoT products. This concludes our video on monitoring and firmware update. And as always, you can go to Pelion.com or Cypress.com/PSoC64 for more information. Thanks a lot for watching this video.